Hi everyone, let's take a look at number 17 on page 47. Does the limit of x squared plus the absolute value of x minus 1 all over the absolute value of x minus 1 as x is approaching to 1 exist? Illustrate your answer by sketching a graph of the function. So step 1, we're going to add a diagram at the top, and we're going to update this as we're solving this case by case. So if you look at the scale, we're going to go up and down, left and right by 4. So 4 in each direction. Now, I'm dividing this into 2 different columns, and I'm going to solve this in 2 different cases. So again, by inspection, because there's the absolute value sign, it's telling you that there are 2 cases. There's the positive case, there's the negative case. Or you can think about this as a piecewise function. So if I start with the left-hand side, I take the limit as x is approaching to 1 from the negative side. And I can copy the entire function first. So x squared plus the absolute value of x minus 1 all over the absolute value of x minus 1. Now, because I'm taking the left side or left-sided limit, this means I have to rewrite this with a negative at the front. So when I write down x squared, I no longer write down plus x minus 1. It's going to be minus x minus 1 all over negative, in brackets, x minus 1. So again, don't forget the 3 steps behind limits. You have to plug it in. If it doesn't work, you have to factor. And if that doesn't work, you have to multiply by its conjugate. It depends on the actual limit. So we have to collect like terms first. And if you look at this carefully, this would give you x squared minus x plus 1 minus 1 all over. And again, if you look at the denominator, that's going to be negative x plus 1. So when you collect like terms, 1 minus 1 would give you 0. And you have to go back and start factoring. So this would give you the limit as x is approaching to 1 from the negative side. There's a common factor of x at the top. So in the brackets, it's going to be x minus 1. And if you look at the denominator, again, we just factored it. I'm going to factor it again, just like that. And you cross this out, and that equals to 1. That's an indicator the factoring is working. And of course, mentally, what I did was I thought about the first step. I plug in 1, which would have given you 0 divided by 0. That's indeterminate. And that's why I move on to step 2, which is factoring. Never skip step 1. So now that I factor x minus 1 from the top and the bottom, I go back to step 1 and I plug in x to be 1. So in this case, this is going to be 1 divided by negative 1, which equals to negative 1. Now, you want to be mindful, at this part of the limit, the function basically equals to negative x. And because looking at the left-sided limit, or the from the negative side, and this is the graph that you're thinking about for x less than 1. So again, we don't include 1. It's x less than 1. So we go back to the graph, and we add this. So if you think about the graph, there's going to be a circle here, and the slope is negative 1, and it looks something like that. So likewise, if you move on to the second column, I take the limit as x is approaching to 1 from the positive side. Again, x squared plus the absolute value of x minus 1 all over the absolute value of x minus 1. So in this case, again, mentally, I'm going to plug in x to be 1. And when you do that, this again will give you 0 divided by 0, which is indeterminate. So now you move on to step 2. You're thinking about factoring. But before you factor, you have to look at the fact that this is a right-sided limit. So this becomes x squared plus x minus 1 in brackets minus 1 all over x minus 1 in brackets. And again, I'm going to collect like terms. When you expand this is going to be x squared plus x minus 1 all over x minus 1. And this equals to, again, the limit as x is approaching to 1 from the positive side. This is x squared plus x minus 2 divided by x minus 1. So I'm thinking about factoring, and when you factor the numerator, this would give you the limit as x is approaching to 1 from the positive side. This is simple factoring. One of them is going to be x minus 1 times x plus 2 all over x minus 1. And again, the fact that you can cross out x minus 1 divided by x minus 1 is an indicator the factoring is working and you're getting closer to the final answer. So I go back to step 1. I plug in x to be 1. 1 plus 2 is going to be 3. And again, just be mindful that at this part of the limit, the function reduces to y equal to x plus 2 for x greater than 1. So I'm going back to the graph. I'm going to update the second piece. So the y-intercept is going to be at 2, and the slope is going to be 1. So it's going to look something like that. And again, this is the entire function, right? F of x. Now, the question says, does this limit exist? So you check the left limit, it's negative 1. You check the right limit, it's positive 3. However, since the left limit does not equal to the right limit, therefore, the limit of f of x as x approaches to 1 does not exist. I hope this makes sense.